In this session, we are going to understand an important system called from the exec family called execlp, execlp. Before I explain the syntax, let me clearly state one powerful idea. Like execlp does not create a new process. It replaces current process image with the new program. This means same process ID, same process, completely new program loaded in memory. And that is the most important concept of this today's session. So let us understand first what is this execlp. Execlp is a system call that replaces the current running program with another executable program. And as we can see here, it belongs to the exec family. Now here, let us understand the two important letters with the system call. So it contains first L. L means arguments are passed as a list, correct? And P, the system searches for the program in the path environment variable. So, and this is the main difference from execl. Like in execl, if you recall, we must give full path, like say for example, /bin/ls, which we did in earlier session. In execlp, we can simply write ls and the system finds it automatically. So let us understand what the syntax contains. The syntax has some parameters, okay, ending with null. The first argument is the program name, and arguments are passed one by one. And as I said, it must end with null. On success, it never returns, and on failure, it returns -1. So if execlp succeeds, the next line of code will never get executed. Now I referred to something called as path earlier, an environment variable. So let us say when I write ls, the shell searches here, like for if I go back and if I write ls, the shell searches for ls in directory listed in the path. Now, how can I check the path? So one can just write echo dollar path. So this is an environment variable. So execlp uses the same mechanism. Like for example, if I write this, you can see the path is separated. Like what are the parameters that are added with path are separated by colon. So /bin one can see here, and we know ls can be found in /bin. So when we wrote execl, we wrote /bin/ls, then ls, then -l, and then null. Here we will write it like this. So for example, execlp, then you will just write ls here, then the arguments -l, and then ending with null. Correct. So like ls, this is the program. What it will do now when you use it with this when you give this call in the path variable, it will try to find either of these. What are the different paths that are where exactly ls is? So wherever it finds, it hires this one. Okay. So like one can see here, it is searching USR bin, USR local S bin, USR local bin, correct? USR S bin, USR bin, S bin, /USR/games. These are the paths that are added there. And then it finds what are the file name that you provide here as a first parameter in the respective path. So let us try to understand this with the demo program. And so let me write Emacs. So execlp.c. So as usual, we'll write #include stdio.h, then #include unistd.h. Then we know we have to call main function. And in this, let us write printf before all to execlp/n. then execlp ls, as I stated earlier, ls, then dash l, and ending with null. Fine. And then like we'll write another printf after call to execl. Correct? And then towards end, we'll write return. Fine. Now let us save this code by completing the bracket, and let us compile gcc execlp dot c. Correct. Now, if I execute, like what will happen when I execute? What is happening in the code? So our code is execlp dot c. What is happening here? So it will be printing this before call to execlp. Then it will execute execlp with the first parameter to be ls. So it will be searching for ls in the path variable. Then process image for a dot out would be replaced by ls, and directory listing will appear. And if it, like as we know, it is going to execute it successfully. That's why it will not display this printf after a call to execl, because the old program doesn't exist when you execute execlp. Correct. So let us do this. So it would be difficult for us to rather check whether what exactly happened. Correct. Within the fraction of time, everything gets executed. And let us do this with a fork call. Okay. So let us write fork with execlp. Now, in the same way, we write hash include stdio dot h hash include unistd dot h hash include sys slash types dot h. Then int main. Then we will define PID structure variable as PID, and we'll give call to fork function. Correct? And in the child, we'll try to execute that ls thing. Correct? Let us check. So if PID is equal to 0, then it should execute that printf like the way that we earlier wrote before call to execlp, or one can say we can write here, like because we are executing in child process is executing ls command or ls command. Right? Then we'll give call to execlp. Then as we are aware, we'll write this ending with null. Fine. Now we'll assume it will work properly. Correct. So because why? So we know that there is no problem in executing that ls command, definitely. So this is how you are going to give call. And else, like else would be a simple printf. We'll write this is for parent process. So parent process should display this, and in child process, it should display the other part. Correct? Done. This is done. Then we are going to write return 0. Return 0 bracket complete. Fine. Now what will happen here? Parent would be creating a child. Now child a dot out, like what the a dot out would be, it would be changed. Okay, with ls. So one can write here to wait, ask to wait it for some time, so that one can see whether a dot out one child is generated or not. So parent creates a child, child replaces itself with ls, and parent continues running. Okay, so you can add here again get char for the sake of checking it. And this is exactly how the shell is working internally. Like when I stated that what is happening in bash, you are writing ls. That means bash creates a bash. Then the child bash would be replaced by ls. And that's what is happening. So similarly, we are going to do the same thing with what you can say like our a dot out instead of bash. Well, let us save. Hopefully there is no error. Let us check. Good. So if I execute, now if I try and checking it, I try checking with ps dash ejh. So we should see now two children's, like one child and one parent, 460 and 461. Now what should happen? Like it is waiting for my input as a character. So I gave it. So let us say 460 and 461 are two processes. Correct. So I will press enter here. Then it should uh, finish that parent. So 460 and 461. Let us check what is remaining. Only 461 is remaining. 460 parent process gone. Now this a dot out would be replaced by errors dash l. So if I add one more character here, you can see, correct? So as the process has completed execution, it is expecting that bash. So for example, this. So actually the cursor that was there is expecting a bash. Now, while we tried finding out this, what I want right now is to see, like for example, here when we saw a dot out and a dot out is shown to us, like in earlier case. For example, when I execute this code again, correct, and if I write PS, I want to see like what would be there, like what when we say that the child would be replaced by its image, I want to see that image there, correct? How can I see that? Probably maybe with respect to the child or maybe with respect to the process itself. How to do it? So let us try to understand how to observe process image change using PS. Now this is one of the most important practical experiment. Now we want to visually confirm that PID remains the same and command changes. Let us write again a modified demo program. Let us write the same thing. So I will not use fork now for a while. You can do that as a task for you to work with a fork system call and this execlp with what I am trying to show now currently. Hash include unistd. So I will use say a sleep function call. Sleep means we want to ask system to sleep for some n number of time units. Int main. Printf. So I want to now anyway like this is a child generated, so this our executable would be getting some PID, correct? So we'll display that PID %d slash n, and I'm writing get PID function call, correct? Now let us ask this process to wait for say 10 minutes, sleep for 10 minutes. Now I am giving call to execlp, and here I will be calling sleep again. Now here for this newly to be replaced, what you can say call or a image, I will add now instead of 10, I will add 30, correct? And then towards end I have to write null, correct? And then we will write return 0. Our bracket complete. Let us save this. Then you will really see like how exactly a dot out will be manipulated. So let us compile. We want to see how the image gets replaced. So GCC Now, if I execute this, now for a while, let me tell you what is sleep. So sleep is a delay for a specified amount of time. So you can specifically write. Generally, like we are going to give a number, right? So let us execute this code. So you can write even this and the sleep because we are giving a call to function. So it is specified number of seconds. This is what we used. Okay, the sleep function call. The earlier sleep was the shell command, correct? So let us execute the code and let us see what is 13. The PID that we got is 13696. Let us check. This is 13696. We'll keep it. Okay, let us write again ps-cjh. Now you can see the same process ID is replaced now. This PID would be there, but the image of a.out is replaced by now sleep. Once the 30 seconds time minute goes, this process will be removed from the system. Let us keep eye on 696. So still it is there because it should execute that. Now it is done. You can see now next cycle when we write ps-cjh, 696 will be removed because it is gone. Correct? And that's how you can see. So what we observed here, we saw a PID, correct? And then we ultimately got the things. Correct. Now after like PID is not changing, but the command changed from our executable name dot slash dot out to sleep, correct? For what are the 30 time units. And that provides and like that proves that the process image has been replaced. So internally what happened? Code segment got replaced, data segment got replaced, stack and heap also got replaced. Everything changed except the PID. Right. So if at all, like I'm providing you one more command to see this. How can you do that instead of writing this? So you can write watch dash n l. Let us okay. Let us write this one. Sorry, not l one. Then you write ps dash p. And what is the PID that we got? 13784. 13784. Just let us write dash o PID PPID, right, and CM. So the process already completed execution. So we'll write this one more time and we'll replace this. Our PID is now 13859. Okay, so what we'll do is we will add instead of 10, we'll write 15 there because we have to manipulate that and check the things. So we'll write 30 only there instead of 10 so that we can get time to change PID. Right? Let me compile the code. Sorry. Let me compile the code. Done. This is what I got. So let me replace it by 1414023. And let us see what is happening here. Right, 14043. Let us see what is happening. Now this refreshes after every second. So once the 30-second time passes, this head out output will be replaced by sleep 30. Now you can see what exactly happened. Correct? So this live transition makes this concept very clear. Correct? So what we saw was like we gave a dot out. I will try it one more time for you peoples to get clear understanding of what is happening here. What we did, we are giving call to sleep. Okay, through the process before giving call to execlp, we are writing sleep so as we can ask it for wait purpose. You can replace it by scanf2 with one of the scanf so that you can write that PID getting replaced there. But suddenly, like when you execute that and press enter, it will be changing. So that's why I added that delay there too. And like when execlp, I'm calling the same function again. So we got 14231. Let us check it. 14231. Now what would be happening here? After every second, this is getting refreshed. You can see this cursor. Let us assume that it is refreshing. And once that 30 is achieved, okay, what you will see in CMD, A dot out would be replaced by sleep 30. Correct? Let us wait for it again. And we'll realize like once this 30-second mark is done, now one can see same PID remained there, 14231, and now it is executing sleep 30. Correct? So we used watch command to keep eye on this. So let us summarize this. So when should we use execlp? We should use it when we don't have or we don't want to specifically write the full path. And we are aware that the program exists in the path. What are the variable values that are that path environment variable is having? Those values in such cases that would be correct. Fine. And arguments are fixed and known. Now, if arguments are dynamic, then we have to use something else. So in next session, we will talk about exec VP. Okay, where we will see like when arguments are dynamic, what to do. Let us summarize again. Like what we did, exec LP, we gave call, it replaces current process. What are the value, whatever the parameter that you gave, it searches that executable in path, takes arguments as list, never returns on success, and commonly used generally after the fork. So right now, though we haven't used it that way, but just to show you what is happening, we used it earlier with LS. So what is happening with exec LP? Keep the same process body and load completely new brain into it. And we will use PS, let us, as a witness to see that transformation live. Thank you.